The proposed indoor sports stadium located in Barangay Darasa, Tanauan City, Batangas, a portion of the project Tanauan City Senior High School with City Sports Complex, is to cater 5,500 capacities in a 72 meters by 88 meters anticipated lot area. To conduct good sightline analysis, the designers follow the standard calculations for the proper width and height of the benches, since it is a critical component of providing safe seated accommodations as it provides a complete perspective of the playing field. The design of trusses also performs as an effective shading for a spectator's better viewing experience as it balances the temperature, humidity, and the intensity of light. The spherical shape of the dome roof allows air and energy to circulate without obstruction. The space frame was chosen to be built as a grid type for it offers significant benefits in terms of structural modulation. Since the roof is a rounded rectangle, the tension ring cannot properly limit the roof's edge displacement. To aid in the Y-direction restraining action, an additional subtensioning member must be installed. The shape resistance of the roof structure is poor due to its low span rise ratio. As the tension ring with the tension trusses share its stress, the deflection was drastically reduced. In terms of designing the structure considering the seismic load, engineers have always chosen to consider accidental torsion since the movement of earthquakes is unprecedented and it varies from time to time. The researchers also considered the orthogonal effect with the aid of Uniform Building Code 1997. According to the analysis, the columns on the first and second floors are unable to provide adequate shear resistance during an earthquake, resulting in extreme soft status. To help with the problem, the designers incorporated shear walls. However, as the column design progresses, the above columns generated the same analysis due to the non-resisting moment of steel-to-concrete connections. To address this issue, the designers added bracing to the columns that can move in both the X and Z directions. The indoor stadium is a composite structure since it is composed of steel and concrete, and the most justifiable framing system to use is a dual system. The steel structure was designed by considering mode of failure and limit states. Since columns are prone to buckling, a buckling analysis was applied on the structure to see how it would buckle due to various factors. Using the buckling factor, the researchers determined how much value of load is required for the system to buckle. Shear connections, moment connections, and base plate connections are three types of connections considered among various types of Bentley connections. An interaction diagram depicts the combination of structural members' allowable moment and axial capabilities. To be regarded safe, the combination of action effects from the interaction curve must be smaller than the combination of design strengths from the interaction curve. Given the size of the structure, foundation design is one of the most difficult aspects. Having said that, the designers are left with two options: using both isolated and combined footing with a 5-meter depth that meets 195 kilopascal bearing capacity provided by the soil test, or maintaining the 2.5-meter soil depth of footing and its 100 kilopascal capacity, but using mat footing. The latter was considered for the purposes of the study, but the isolated footing was chosen due to its lower cost. This leads to the conclusion that the foundation's chosen alternative resulted in a better design with an economic advantage. Finally, the researchers adhere to all requirements and provisions, resulting in a lower cost for the best design output.